When we humans look at the universe around us, we're blown away by the complexity and the diversity of all the things we see, from the scale of things in the cosmos, like stars. This is a picture of our sun, all the way down to a more human scale, and all the way down to the microscopic scale. This is a visualization of a coronavirus. It seems like there's an infinite number of things out there. But an interesting question has always been, are there some basic building blocks, things, a smaller set, a finite set of things that we can put together to make up all of this complexity? Ancients thought about maybe it's fire, water, wind, but now we know that there are things called elements, and we have classified them on the periodic table of elements. And we know today of about 118 elements, but we might discover more. But what's mind-blowing is all matter that we know of in the universe is made up of combinations of these elements. Now, what's even more amazing is most of what we experience in our everyday lives is made up of an even smaller subset of these elements. For example, almost 99% of the mass on Earth is made up of these 8 elements. And if we look at ourselves, if you were to stare at your hand or look in the mirror, life as we know it is made up of mainly these 6 elements: hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. Now, the Earth and life is made up of other elements, but it is amazing how much complexity and how much can be made with combinations of the things that we see in the periodic table of elements. Now, the next question is, all right, we can make things out of these elements, but what if we were to keep cutting an element, or what if we were to keep cutting a substance down? What is the smallest unit that still maintains the properties of an element? And that unit, you have probably heard the word, is known as an atom. And atoms can be further broken down. In fact, an atom has a nucleus, and inside that nucleus it has subatomic particles known as protons and neutrons in that nucleus. And then you can imagine buzzing around, and we're talking about very, very small scale, and it's hard to pinpoint. It's more of a probability where you might find these, but buzzing around that nucleus, you have electrons. And the protons have a positive charge, the neutrons have a neutral charge, and the electrons have a negative charge. But everything we're talking about is made up of combinations of these 3 fundamental particles. And what's especially cool is a given atom is mostly free space. You have the dense nucleus, but then these atoms are just buzzing around in mostly free space. And what actually gives an atom the properties of a specific element is the number of protons we're dealing with. So, for example, what makes an atom a hydrogen is it has 1 proton. What makes an atom a chlorine is that it has 17 protons. The number of electrons can change. That will change its charge, and that might change how it interacts with other atoms, but it still will be classified as a, for example, carbon, regardless of how many electrons it has. And similarly, the number of neutrons don't affect its charge, but it will affect the mass that we're dealing with. But even if you change the number of neutrons, you're still, and you have the same number of protons, you're still dealing, if you say you have 6 protons, no matter how many neutrons or electrons you have, you're still dealing with carbon. And it's really interesting to appreciate just how small atoms are. If you think about it just as a number, the width of, let's say, a carbon atom, and there are smaller atoms like a hydrogen atom or a helium atom, but the width of a carbon atom is roughly 1 times 10 to the negative 10th meters. Another way to think about it, and it depends on the context you're seeing the carbon, but roughly speaking, if you took 10 billion carbons and put them side by side, it would be about a meter wide. Or, if you want to blow your mind even further, if you had about 10 million carbons and put them side by side, that would be about a millimeter. So try to approximate a millimeter. A millimeter, depending on the resolution on your screen, might be something like that. There would be 10 million carbons, depending on how big you're looking at this video, just in that space over there. If that doesn't blow your mind enough, another way to think about it is it's estimated that there are more atoms in a grain of sand than there are grains of sand in all of the beaches on Earth. And if that doesn't blow your mind, roughly speaking, if you took an apple and if you made the apple the size of the Earth, then an atom in that apple would be the size of an apple. You can hear that again and process that. If you took, or another way to think about it, an atom of an apple is to the apple as an apple is to all of Earth. So atoms are tiny, tiny, tiny. So I'm going to leave you there. That's enough mind-blowing for one video. And then in future videos, we'll discuss more in depth about atoms and the subatomic particles that make them up. And we'll talk more about classifying the different types of matter.